right, so we've taken a look at direct variation, which we know is y is equal to kx. We've looked at inverse, which we know is y equals k over x. Now we're going to look at joint. Now, joint variation is basically just saying that you can do more than two variables at a time. So W is jointly proportional to x and y, means y equals k times x times y for some non-zero constant k. So we've already done this. It's just a matter of lumping them together. So let's take a look. Example number 5. The volume V of a right circular cone is jointly proportional to the square of its radius times its height. Find the equation of variation if a cone of height 8 inches and radius 3 has a volume of 24 pi cubic inches. So when does 24 pi equal k times 3 squared times 8? So now we simplify. And we get what? 3 squared is 9 times 8 is 72. Divide both sides by 72. And you get what? 1/3 pi is equal to k. So find the equation would be y is equal to 1/3 pi times your radius squared times your height. All right, this next problem is pretty interesting. Really got me thinking. So the frequency f of a vibrating guitar string is directly proportional to the square root of the tension and inversely proportional to the length. Now, you don't need to put another k in because it said in one part direct and the other part inverse, just in one spot. What is the effect of the frequency if the length is doubled and the tension is quadrupled? So F will equal K. Let's see, we're going to quadruple the tension and we're going to double the length. Well, if we leave it like this, I don't know about you, but nothing jumps out to me. I'm not exactly sure. So we have to clean it up. So F will equal K times, let's see, 2 times the square root of t over 2L. How did I get that 2? Well, the square root of 4 is 2. The 2's cancel each other, so I'm left with F is equal to K times the square root of t over L. So what's the effect? There is no effect. When you simplify it, it's the exact same equation that we started with. So your answer, no effect.